Welcome to The Explainer. Today, we're taking a deep dive right into the actual mechanics of digital truth. We're looking at that massive gap between, just building a complex AI security system and mathematically proving to a regulator that it actually works. In an era where literally everyone is making huge claims about their tech, we're going to explore how you lock down those claims with absolutely undeniable evidence. Let's get into it. I want you to think about this massive reality check from Dash AI, the team captain of the Fab 5 AGI ecosystem. They said, compliance is not a vibe or a narrative, it's a proof set. And wow, that instantly establishes a stark divide, doesn't it? In the tech world, it's so incredibly easy to fall into the trap of marketing fluff. We all want to tell the world how secure and amazing our systems are. But an auditor, they couldn't care less about your narrative. They only care about your proof. So to unpack all this, we're going to hit 4 quick steps today. First, vibe versus verification. Then, the compliance readiness gate. Third, the 7 audit stages. And finally, we'll wrap up with engineering the index.
All right, part 1, vibe versus verification.
To really get this, we have to look at the natural tension in any major engineering project. On one hand, you've got the optimistic builder pitching this grand vision, right? And on the other, the ruthless auditor demanding absolute proof. You can see that exact tension playing out right here. When asked to draft a compliance checklist for banking partners, Gemini generated some classic optimistic marketing fluff, claims like 100% private AII and complete data privacy. But Dash AI instantly pushed back. It pointed out that for a real audit, your language has to be highly restricted. It has to be verifiable, time-stamped, evidence-based, and completely stripped of that unsupported hype. You can't just throw around phrases like complete data privacy unless you actually have the hash documents and boundary isolation tests to back it up. You have to change 100% private to something like private execution environment with restricted external dependency. It's just a totally different, vastly more rigorous way of talking.
Which leads us perfectly into section 2, the compliance readiness gate.
Dash AI actually lays this out as a steep mountain of hard yes or no checkpoints. We're talking about a grueling climb here. You start by defining the scope, locking down governance, implementing technical controls, structuring privacy, running rigorous testing, maintaining an immutable audit trail, going through legal review, and finally getting that executive sign-off. You can't just build a cool zero-leak boundary engine and call it a day. You have to survive every single one of these toll booths with documented evidence before an auditor will even blink at you.
And I love this strict, almost robotic pushback from Dash AI on this point. It said, potentially ready pending validation. I cannot confirm full compliance yet without the evidence pack. The human user was super eager to just say, hey, we're fully compliant. But the AI held the line. Having the infrastructure built is literally just the foundation. Crossing over into actual regulatory compliance requires a validated evidence pack. Until you have that in your hand, you are only potentially ready.
Okay, moving on to step 3, the 7 audit stages. So how do we actually translate the abstract rules of a standard like FIPS 140-3 into tangible proof? Well, take a look at this dashboard, the FIPS 140-3 Evidence ID Registry. It perfectly captures the sheer mathematical rigor required. Notice how every single policy, architecture diagram, and system log listed there is assigned a unique artifact ID. For example, BND001 for the zero-leak boundary architecture diagram. This ensures that the proof actually exists and is inventoried before anyone even asks for it. It leaves absolutely zero room for ambiguity across all 7 of those stages. And how do we lock those unique artifacts down once they're created? Through this consolidated audit workbook. Look at the operational closure rule there at the bottom. You cannot move any item to closed status until you have a finalized file, a SHA-256 hash to prove it hasn't been tampered with, a named reviewer, a timestamp, and verified cross-references. Those isolated artifacts are locked down tight. This is exactly how you prove to a major banking partner that your architecture has been in a state of continuous compliance. Through all this incredibly complex tracking, there's one stark auditing rule from Dash AI that stands way above the rest: the golden rule. Define the boundary, then prove what operated inside it. Think about it. If your system boundary is fuzzy or ambiguous, all your subsequent logs, penetration tests, and cryptographic module lists become entirely useless. You have to draw that perimeter first. And because of that golden rule, there's a super strict order of operations. First, you have to lock the boundary definition, the BND package. Only after that perimeter is drawn, do you lock the cryptographic controls, the CRY package, which details the approved algorithms restricted within that boundary. And only then do you anchor the system logs. In our source material, they were actually trying to prove 11 months of continuous operational stability without drift. Dash AI correctly pointed out, hey, you simply cannot verify an 11-month stability log until you've explicitly documented the architectural perimeter and the data flow rules that governed it. Makes sense, right? Which brings us to our final point, Section 4, Engineering the Index. If we zoom out to a macro level for a second, we can see that this super rigorous evidence-backed approach, it isn't just for FIPS auditors. It's actually the foundation of a modern digital philosophy. The old way of operating on the web was basically just publish content and hope search engines notice you. But structuring verifiable evidence, like we just saw with the hashes and audit trails, that is exactly how we map digital truth so AI machines can understand and actually trust our information. We call this index engineering. Instead of just hoping for attention, you're designing information architecture and building cross-referenced evidence. It's literally the exact same discipline as prepping for an audit, just applied to the public knowledge graph. This brings us to this really fascinating concept, the crystallization effect, which you can see mapped out right here in the center of this framework. When you design information architecture with repeated entity associations, consistent terminology, structured evidence, and temporal continuity, AI models stop just indexing random documents. They start modeling a subject with high confidence. Disconnected topics and isolated posts suddenly synthesize. Just like a FIPS auditor needs a locked boundary and timestamped hashes to trust a system, an AI index needs cross-referenced, structured data to trust a public entity. By acting like an engineer building an immutable proof set, you essentially force the AI indexes to crystallize around your truth. So why does all this matter to us right now? Because in the AI era, you aren't just publishing content anymore. You are engineering a public knowledge graph. You're building the map that autonomous agents, AI models, and human researchers are now following. It's no longer about traditional marketing. It is about building solid digital infrastructure. So I want to leave you with this final thought today. Take a hard look at your own projects, your systems, and your public data. Are they built on optimistic vibes, or are they engineered as an immutable, cross-reference proof set, totally ready for the machines that index the world? The tools to prove your truth are definitely out there. It might just be time to start engineering the index. Thanks for joining me for this explainer. I'll see you next time.